Okay, so in regard to your do now problem, we're looking for a conversion between atoms and grams. And remember, as we said the other day, if moles is not given or asked for, it's going to be a multi-step process. And we just did one of these the other day when we started our chapter on the mole. And the goals for this chapter are not only to understand what a mole is in chemistry, how it's used, but also we're going to be getting into conversions involving the mole, as well as empirical formula, molecular formula, percent composition. So there's a lot we're going to be covering in this chapter. So in regard to your do now, I'm going to reveal the answer. And let's see how many of you were correct in your analysis. I'm not so sure how well that's showing here. All right. So this is number 6, where you went from 150 grams to atoms, given 3 sig figs, giving me back 3 sig figs. Were we successful? Yes? Couple boo-boos? So the question is, where are your mistakes? Did you know to convert from mass to moles here by using the periodic table? We said the other day that 1 mole of anything is equal to the mass in grams from the periodic table. So you look up barium. Barium has a molar mass of 137.33 grams per mole. So for every 1 mole of it, you have that many grams. There's the conversion to moles. Then we convert from moles to atoms using Avogadro's constant. So were you successful in your setup and not in your calculation, or are you having issues with the setup? Or you got it right? What do we got? What do we got? Who's alive? The multi-view, if you have a multi-view, just be careful. You'll often need parentheses and denominators where other calculators don't. You shouldn't have needed them in this one, though. Does anybody need to borrow a calculator? You're good? And if you need a periodic table, they're on my desk. Did you get it right? Yes? Yes? And how'd you do with the classwork that I had asked you to do from the other day? You were successful there as well? Yes, yes? I know you have your project due Friday, so. All right, and for those of you who weren't here Monday, we did simple conversions like this. We're going to do more of them today with compounds instead of elements, so they'll be a little harder, but you'll be fine with it. We're scheduling your quiz for Tuesday next week, as well as doing the lab, and then the test will be the following week, so that we have a lot of time to review for the semester exam. Okay, so this is a simple conversion from an element to the same element, converting from mass to atoms. Again, if the mole is given or asked for, it's a one-step process in this chapter. And if you're given atoms and asked for mass or vice versa, it's going to be a multi-step process where you go through the mole. What we're going to introduce today is we are going to relate the mole concept that we began talking about the other day to compounds, both ionic and molecular. So both ionic and molecular compounds. Back in chapter 5, we learned how to name and write chemical formulas for ionic compounds, and in chapter 6, we did so for covalent ones. It's critically important that you're successful in that regard. And many of you did extremely well on the previous test, so I think you have demonstrated mastery for those concepts. You will be asked to write chemical formulas in this chapter, and then you'll be building upon them. So, we're going to relate the mole concept to chemical formulas. We know in an ionic compound, we have the simplest whole number ratio of ions. And that's why when you swap and drop, you then reduce those numbers. So you don't leave a 2 and a 4, you get down to a 1 and a 2, because it would be 1 cation to 2 anions in that case. So the reducing is important. We deal with formula units for ionic compounds because we've reduced those subscripts to the simplest whole number ratios. So when we're talking about mass for 1 mole of an ionic compound, we call it formula mass. When we were dealing with mass for 1 mole of an element, we called it molar mass. So this will be formula mass, but it's all processed the same way. For example, it says determine the formula mass of potassium bromide. Now here I did write the chemical formula for you. That's something you're able to do already, so it's not something I'd give you on the quiz. We want to know the formula mass of potassium bromide. That is the mass in grams of 1 mole of the compound. Potassium bromide has 1 potassium ion and 1 bromide ion. So I'm just going to represent it as an element here because electron loss or gain is not going to impact the mass. 1 potassium, so I have 1 of them. The molar mass of potassium off the periodic table. We have 1 bromine atom, 1 of them, molar mass of bromine. To get the formula mass of the ionic compound, 1 times 39.098 grams per mole plus 1 times 79.904 grams per mole. Formula mass of 119.002 grams per mole. In regard to sig figs, I go off the least number of decimal places, which is 3, formula mass. If I want to write this as an equivalency, which you'll need for a conversion, instead of doing grams per mole, I say that 1 mole of the substance, in this case potassium bromide, is equal to the mass in grams of the same substance. If I had a substance such as calcium chloride, I would formula write it. Here I've got 1 calcium to every 2 chloride ions. So 1 calcium, 2 chloride ions, 1 times the molar mass of calcium from the periodic table, plus 2 times the molar mass of chlorine from the periodic table, 1 times 40.08 plus 2 times 35.453 is 110.99 grams per mole. I can write an equivalency. 1 mole of the substance is equal to the mass in grams of the substance. So let's do one from scratch so you can see exactly how to work it step by step. I think you'll find this to be relatively straightforward. Again, be very careful on your formula writing so that we know that you're successful at that step. That'll set you up for greater success. So in this problem, it says, calculate the formula mass of iron 2-phosphate in grams per mole. So let's take a look at how to work through this problem carefully. Okay. First thing I need to do is write the chemical formula for iron 2-phosphate. And again, you've already been assessed on this. You are very successful formula writers. Have to specify the charge on iron because iron is a transition element that can form ions of multiple charges due to D-filling orbitals. Iron 2-phosphate. Once you write the chemical formula, now what you want to do is count up the atoms just like we learned back in chapter 2. We have 3 iron. We have 2 phosphorus, and 2 times 4 is 8 oxygen. So we've counted the atoms. Now, Chris and Sydney, you can get even closer today. You guys always have the worst seats in the house. Look, front row seat. You want to come closer? You're good?
Yeah.
Okay, because this is closer, so you don't want to get too close. I get it. I'm just teasing. You guys are doing well, so I won't bother you. All right, now I get the molar mass of each one. I look at my periodic table. The atomic mass of iron is 55.847. Instead of writing AMU, I do grams per moles as we talked about the other day. Phosphorus. What is the molar mass of phosphorus? 30.974 grams per mole. And oxygen, you'll know this one in no time because we use it all the time, 15.999 grams per mole. Now to get the formula mass, in our calculators, you're not going to have to do this in your heads. So you can take out your calculator. Does anybody need one? You're good? Okay. So we have 3 times 55.847 plus 2 times 30.974 plus 8 times 15.999, and that's going to be 357.481 grams per mole as the formula mass for iron 2 phosphate. So very systematically. They didn't ask you to write an equivalency, but I just want to point this out to you. If asked to write an equivalency, that would be 1 mole of the substance is equal to the mass in grams. Questions on formula mass? Right, there's another problem here. It's for strontium chloride. Do you want to do it together or you want to try it? Try? Okay. I'm going to flip screens in a minute because it'll be on the screen and I can work it out for you. Actually, I think I have it worked out, so I can just leave that there. Oh, because that was a double stepper and we hadn't really done that much. Are you guys good? What'd you get? Just about. And this really isn't that big of a deal. You know I'm a sig fig crazy person, but this is going to be used in some type of conversion. Your formula mass for strontium chloride is right here. And I got down to 2 decimal places because the molar mass of strontium was to the 100th place. So I reported it as such. It's really not a big deal. All right? You're going to need the equivalency because that's what you're going to see in about 5 minutes.
Isn't there like specific rules for fives? Like
there are
rounding?
specific rules for fives, but you wouldn't have seen it here. If, for example, you were asked to round this to the ones place, and you had 222.52, if an even number is followed by a 5 and a 5 only, you round down to 222. If you have an even number followed by a 5 and any other number than 0 after that 5, then you automatically round up. So if you were asked to round this to the ones place, you would round it to 223. Okay? And that's something we'll make sure we're continuing to do, is review our rounding as well as our sig figs, because sig figs are going to come back in full force now. All right, so that's how you calculate formula mass, and formula mass is for an ionic compound. And we're going to calculate molecular mass now, which is done exactly the same way. The only thing is, for molecular mass, that's for a covalent compound. Covalent compounds make up molecules. Here the subscripts in a covalent compound indicate how many of each atom you really have. That's why you don't reduce for covalent compounds. If you have dinitrogen tetroxide, you have N2O4. You don't reduce it down for a covalent compound because the subscripts indicate how many of each you truly have. So for example here, we're asked to calculate the molecular mass first for carbon dioxide. Carbon dioxide is a covalent compound. Its molecular mass would be calculated the exact same way that we did so previously. I think my little pen is dying. There we go. You have 1 carbon in carbon dioxide, 2 oxygen in carbon dioxide. 1 times the molar mass of carbon plus 2 times the molar mass of oxygen is equal to 44.009 grams per mole. Molecular mass instead of formula mass. If you had glucose, which is a simple monosaccharide that some of you may have picked for your project, just be careful in your project if you're picking some complicated covalent compounds. You're really going to want to look at their structures on the internet, because if you try and guess it, you probably are going to have some issues with it. If you pick structures off the internet, that's fine. Some of you don't really know what condensed structural formulas are. You're welcome to ask. If you have oxygens and nitrogens, don't forget the lone pairs there. Glucose is a simple monosaccharide, which you would have learned about in biology. It has a molecular mass of about 180 grams per mole, and we'll be using that one shortly. So with covalent compounds, you find molecular mass. With ionic compounds, you find formula mass, but it's done exactly the same way. And then Haley's like, well, do we have to write the equivalency? It doesn't really matter if you write the equivalency out, but you're going to see in this next section here that we're going to use the equivalencies. The equivalencies were very obvious when we talked about elements like we did at the very beginning in the do now. Here we're going to do equivalencies, that is conversions from moles to molecules, from molecules to moles, from mass to moles, from moles to mass, from mass to molecules, from molecules to mass, back and forth, either one or two step type problems. So here you'll have to make your equivalency. So that's when we're going to use it. And we're going to work through these problems here together. These are basic conversions involving compounds. We're going to have either one or two steps. And it really is very simplistic if you let your units drive your problem. So let's work through the first three. I'll do the first one for you. The second one we'll start to do together. The third one you'll do more for me than I do for you. And by the fourth one you should be ready to fly solo. So let me go back. In the first one, let's make sure we're all comfortable determining the given versus the unknown. It says what mass of lithium phosphide is equivalent to 2.45 moles of lithium phosphide. So we want to know the mass of it. That's what we're looking for. The given has to have a quantity in it, 2.45 moles of the substance. Okay? So we always start with the given, and we're looking for the unknown. So my given is 2.45. I'm going to turn my paper because some of these problems get a little bit lengthy. So this one's not too long, the first one, but then they're going to get long. So in number 1, we have 2.45 moles of lithium phosphide. And we want to know the mass in grams. So just like we set up the other day. My given, what I'm starting with, my unknown, what I'm trying to figure out. And just like we talked about the other day, just like we talked about at the beginning of the year with the factor label method, whatever unit is here must go in the denominator of the first fraction in order to get the units to cancel. So moles of lithium phosphide will cancel. In this chapter, wherever I have moles, I always have 1 mole of it. Now we said the other day that 1 mole of anything is equal to its mass in grams. So this is an ionic compound, a metal and a nonmetal. So a metallic cation and non-metallic anion. So we're going to need our formula mass right here. And this is what we just learned how to do. So we've got 3 lithium, and we've got 1 phosphorus. We can get the formula mass using the periodic table. 3 times the molar mass of lithium off the periodic table. Instead of AMU, we use grams per mole. 1 phosphorus at 30.974 grams per mole. And we have 3 times 6.941 plus 30.974, and that's going to be 51.797 grams per mole as the formula mass. So 1 mole of lithium phosphide has a mass of 51.797 grams. So this is what I meant by equivalency, because here's your equivalency right here. Now we don't put grams per mole up here because I have 1 mole of it. So I'm basically splitting this into the equivalency fraction. Then I just do this times this, and I get in 3 sig figs, because I'm given 3 sig figs, 127 grams of lithium phosphide. Shane, is anybody behind you? No? Okay. Questions on the setup, how to calculate anything. Very systematic, and you'll be successful here. All right, let me reiterate. When given mole or asked for mole, in this chapter it's going to be a one-step problem, so keep it simple. If you're not given or asked for mole, it's going to be 2 steps in this chapter. So in number 2, it says how many particles of sodium sulfate are equivalent to 359 grams of sodium sulfate. So in number 2, what is my given? What am I starting with? 359 grams of sodium sulfate. Good. And what we want to know is particles. And the other day, we had atoms because we were dealing with elements, but here we've got an ionic compound, so we're going to be looking at particles. If you have a covalent compound, you'll be looking for molecules. So I've got the mass, I'm given mass, I'm asked for particles, so this is going to be a 2-step problem, and I want to know particles of sodium sulfate. And again, you can see if the formula writing is still an issue for you, you need to review that concept again. I've given you several classwork assignments, several online tools, also iPad resources. You've got to be solid with your formula writing. You won't lose credit for everything if you don't formula write properly, but you get thrown into the last one to grade pile because I got to figure out all the wrong answers. So be careful there. Watch your formula writing. Most of you are extremely strong formula writers. All right, so if I'm given grams, what should go in the denominator of my first fraction? Grams. And as I mentioned on Monday, I have to, on this quiz, be a grading dot monster. I'm always going to look for 3 pieces in your given, in your fractions, everywhere. So a number, a unit, a substance, a number, a unit, a substance. Now grams is going to come off the periodic table, and we can always go from mass of a substance to moles, because 1 mole of anything is equal to its mass in grams. So we can get that piece in just a second. Sometimes I like to set up all my fractions so that I just keep rolling through the problem. Now I have moles of sodium sulfate here. So what will go in the denominator? 1 mole of it. And what will go in the numerator? Particles of it. And what number always goes with particles, atoms, or molecules? Avogadro's constant. 6.022 times 10 to the 23rd. That is on the back of your periodic table. You do not need to memorize it. So this is essentially the same type of problem that we did in the Do Now a half an hour ago. The only difference is that we have a compound instead of an element. So it's a little more labor intensive to determine the formula mass. But we did this at the beginning and you guys said it was easy. So it's not going to really be an issue for you. 2 sodium, 1 sulfur, 4 oxygen, and then off the periodic table, you'll get all the pieces. You can even put like a little arrow there if you want. You can get the formula mass of sodium sulfate. And I'm just going to fling that right in there. That's going to be 142.042 grams. Don't put grams per mole here. Here you can have grams per mole because that's the formula mass. But when you break it in the fraction, you have 1 mole of it and grams in the other part of it. I'm going to go in and highlight those numbers because this is getting a bit involved, just so you can see exactly what you're throwing into the calculator. And when I do the calculations, I really like to take care of the numerator and then the denominator. Do you guys know how to flip a denominator into a numerator? Yes? I would be surprised if you did, actually. I'll show you. Can you see my calculator there? Does it show? Yes, yes? So see how I already have 142.042 and that's in the denominator for my problem, which my calculator is covering? Can you see now? No. Can you see that combination? Yes, yes? Okay, so I can flip a denominator to the numerator by hitting either my x to the negative 1 button or 1 over x. So I'm going to flip that right there. And then I can just multiply everything in the numerator. It's a nifty little trick, and it's very time-saving, and you're less likely to make a boo-boo by re-entering something. What I get there is 1.52 times 10 to the 24th. Whenever you're solving for particles, atoms, or molecules, look all the way to the right, because you're going to have times 10 to the something. And if you don't look all the way to the right, you're going to make a little calculation error. And you guys don't like to make mistakes. 1.52 times 10 to the 24th particles in 3 sig figs. Do you want me to do that calculation again? Do you want to see how I did it, or you got it? Are you guys alive? All right, I'm just checking. Easy peasy? All right. You walk me through 3. What does 3 say? What's the given? 1.25 times 10 to the 24th particles of what? Aluminum chlorate, correctly formula written. Okay, and what do we want to get to? The mass. So that's got to be 2 steps, right? Alrighty, now what? Who's having trouble? Let's get you in. Who wants to do it? No one's having trouble? All right, Chris, what goes here? And we're gonna list the substance, and what number always goes with particles? That constant, 6.022 times 10 to the 23rd. If you have particles in one part of the fraction, what must you have in the other part? One mole, you got it, good job. All right, so now we're at moles and we want to get to mass. So what goes in the denominator of the second fraction? Sure. 1 mole. And what goes on top? The mass. And where are we going to get that from? You got it. So we have 1 aluminum, 3 chlorine. How many oxygen? 9 is correct. We get aluminum off the periodic table. So that's 277.332. We'll multiply that by particles and divide it by Avogadro's constant. And what'd we get?
I got 428 point. Wait, it's not point, right? Because 428.
I didn't get that. Do you have all the numbers that I have?
No.
What number doesn't match?
277.
Did you do 1 aluminum, 3 chlorine, and 9 O's?
Yeah, I must have just put it in wrong.
Did anybody else get what I got here? Yes? So what answer did you get?
576.
That's what I got. So double check here, Ethan.
Okay. Okay.
Do you see it?
Mm-hmm.
So did you just do a calculator?
Yeah.
Oops, okay. Calculator oopses are no big deal. Okay? So now you know how to get formula mass, you know how to get molecular mass, and you know how to do conversions with them. I'm going to have you try number 4. I'm going to put the answer on the screen. Now on the classwork the other day, I'd asked you to do 1 through 6, 7 through 9. Those of you who did it are in great shape, because now you have to complete through 16. So basically, you should be able to complete 1 through 16 at this point. There's a second tiny lesson that I want to do with you, but I think the best thing to do is make sure you've digested this before the next little lesson, and it'll only take about 15-20 minutes, and then I'll still give you more time to practice. Questions first.
When we're doing the writing out of particles, atoms, and molecules, can we like shorten order?
Abbreviate. Atoms, there's not really an abbreviation for, because ATM is different. For molecules, you can use MOLEC. Don't drop the C because then it looks like a mole. Particles, you could do PART, I guess. Keep it simple. Yes. All right. So all of this fits into our overall learning goal, which is to understand the mole, how you can do conversions with it, and we're going to get into elemental analysis after you've had time to work through this. I will put the answer to number 4 up because I'm going to cut the videotape, but you'll still be able to do it and check your answer. I'm just looking for it here, and I have it all worked out so we can work through it. But I will tell you that the answer to number 4 is going to be 1.19 times 10 to the 24th molecules, and here's the abbreviation that you were looking for, of glucose. So when you do 4, you'll check that answer. In the next 20 so minutes, try and complete through 16. Again, if you did the work that I asked you to do on Monday, you really don't have that much to do. And then we'll pick up with the second lesson that I'll record separately. All right, questions? All right, so let's take about 20-22 minutes for you to work on your classwork to get a better understanding of the mole.